Can you see Math 107?
Yes.
Yeah, it works for a change. Right, so all I'm going to do right now is go to course assignments. And there we go. It's a 3-4 weeker. So this Sunday, you're only going to be doing up to and including 13.2. But I do know that we are going to be doing this stuff anyway, but that won't be due until a week later. Does that make sense? So this Sunday, you only need to get up to 13.2 complete. And then the following week, you'll finish off these two sections in chapter 13. These will not be due this Sunday. These will be due a week on Sunday. And then it's our midterm. So that's what that was. Now let me nip back a bit. And this is not just for Tara, but this is for everyone. When people ask me a question, and I think it's well, they're all good questions, but I think it's a question that others might want, then you'll see me stick it up here. So if you click on this fella, 1116 help, I've done the solution to question 7. And the other ones in that list look very similar to it, right? So it's always a good idea to come and, just see what's around. From time to time, I add details like that. So, any other questions about that? You all know that we are slowly. Oh, darn it in space. I've got issues with my Windows now. Yeah, I got you back. Okay. As you all know that the midterm is coming up. It's okay, did I have it here? Let me tell you the exact date so I'm not guessing. Our midterm exam will be on Tuesday, the 11th of May. Now, that's a biggie because it's going to be a big chunk of your grade will be in that. And that exam, that midterm exam, will be using 11 and 13. So it's going to be all the financial stuff and all the probability stuff. So we've got this week and next week to get the probabilities done, and I'm sure we'll get that done and some. But that's all that's going to be in the midterm. And during the midterm, the questions that you're going to be asked from chapter 11, the finance, each question will be, you'll be given what the formula you should be using in that particular question is. So if I said to you, you're going to buy a house and this is the mortgage rate and this is interest and blah, 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 you'll also be told in that question that you'll use the following formula, in which case it'll save you the stress of trying to figure out. There's probably about 8 formula now, isn't there, in the finance? There's a big chunk of them. So it stops you having to wonder which one goes with which story. So what you're really going to be tested on is being able to use the formula and come up with the answers that you need. Is there any other questions while I'm at it about what's going to happen in the test?
What format is the midterm going to be given?
Right, the way it's going to be given, it's a very good question. Wish I'd thought about that and told you. It's going to be a PDF. Now, the way it's going to work is you're going to turn up to class just like now, and I'm going to see you. In fact, I need to see you so I can check that you're not cheating and there's not someone sitting next to you telling you what to do. So it'll be a normal Zoom class, but on Canvas, there'll be a PDF with the midterm on it. So you go into Canvas and there'll be a link that will say to you, midterm test, and you click on it and it's in front of you. And you don't need to print the midterm or do anything. All you need to do is write down the working on the answers on paper. And then what you'll do is you'll upload it into Canvas. You'll take a picture using a program called Adobe, Adobe Scan, upload it into Canvas, and that's how I get to see it. Right, Julie?
Is it at a specific time?
Yes, it starts at 1 and it finishes at the end of class at 3. 4,
Okay.
sorry. 1 to 4.
Okay. I have.
So
I'm
Tuesday,
getting my
1 to
second-
4.
I'm getting my second vaccine that day, so I just want to know. If I might not be there at the same time.
Well, if it doesn't fit you, we can shift it a little bit, but you know, do you know specifically what windows you will be free?
I should probably be free at that time, but I just want to make sure if I
In case
need
you're
to.
not. If you do, you have to. Are you going to get the jag after it or before it? Do you know when you have to get the jag?
Before.
Right, so you might not make it on the start because you're still driving here and the queue is half an hour longer and you thought it was going to be that kind of thing. Then
Is that her
what we
first
can
shot
just
or
do
her
is
second shot?
I don't think she needs to tell you that.
Okay,
Tara,
let me say it
but she has
differently.
been.
If it's your
she's-
second shot, you may want to plan. Like I've already done both of mine, and everybody that I know that got the second one, it didn't take very long for a lot of us to feel the after effects. And I can't imagine trying to take a math test. I had Spanish and math shortly after I got my second one, and I don't remember the whole day. It was really hard.
Yeah, but that is normally you, Tara. So I don't think we should. Julie, let's just play it by ear. If you turn up late because the queue is big, we'll just add half an hour on to the end, and you know we'll figure that out. If you turn up and you're puking your guts up, then we'll figure out another day to do it, right? So don't stress out of it. We you know, there's workarounds for
Right,
everything.
thank you.
Okay. I am going to put you all on mute because we have some contributors to our Zoom meeting. There we go. Okay. I'm going to do some probability stuff for us. Once we've done that, I'll then move on to section called expected values, and I haven't written down what the darn number is. It'll be 13.2, yeah. So we're going to do some 13.1 probability stuff. I know we kind of covered it, but there's a little bit more I want to do on simple probabilities. And then I'll do expected values, which is 13.2, and then we'll see where we can go from there. So start and kind of overlap, but that's a good place to begin. If you want to find the probability of anything, let's call it event A. It's a very simple formula. On the top, it's the number of ways A can happen. And on the bottom, it's the total number of things that could happen. So let's suppose we did, for example, that a town had 12,000 people in it and 7,500 own a car. Quite an interesting town, that, because it's a big number. So if you wanted to know what's the probability that I pick one person from that town and the person I pick owns a car? It's almost so trivial that you can talk yourself out of it. That's how many people I could have chosen. That's how many have a car. And that's the total number of people that I might have picked. So I think I'll go down there instead of across the way. You can take probabilities and you can write them in 3 formats. Decimal, fraction, percentage. In no particular order, I'm going to do the decimal first. And as a decimal, I get 0.625. And it depends on what WebAssign says. Sometimes they say to 2 decimal places, to 4 decimal places, or 3 or whatever. Whatever it says, you just do it to keep them happy. Now, you could do it as 62.5%. That would be the same answer. So what that would be, there is a 62.5% chance I pick somebody at random in that town and they have a car, they own a car. Now the third one is the fraction filler. That's 7,500 out of 12,000. Except that won't be the correct answer as far as web assign is concerned. Don't you have to simplify fractions? Great. So I don't think I've shown you this yet. Watch this little trick. 7,500 divided by 12,000. Hit enter. There's that decimal we got, right? Hit the math button, which is over here next to the alpha. Hit the math button. Number 1, fractions. And now hit enter. And the answer is 5/8. You see your TI-84 can turn some quite big and ugly fractions into their simplified version. You want to see that step again? Are we good? I need a kind of nod or a shake head or one or the other.
I can do it again.
Do it again. Okay. Since we're going to do it again, Jade, give me a top number. Don't make it weird. I mean, just normal kind of number.
Give you a different number?
Yeah, different number.
4,000.
Oh, okay. It's a big number, but it's nice and round. Okay. I need a bottom number. Keep it kind of round because that one's pretty round.
18,000.
18,000. So you write down your fraction, right? In this case, that divided by that. So as a probability, wouldn't the answer be 0.22222, you know, and you've run it saying twos? Hit the math button, choice number 1, which is called fractions. Hit enter twice, and there's your answer, 2/9.
Okay, thank you.
I could do it with any fraction, right? You all know that 6/10 is 3/5, right? 6 divided by 10, enter. Math button, number 1, which is fractions, enter. So if you're doing any of the WebAssign answers and they want a fraction and it's really big and ugly or just weird, you know, 117 over 392, and you think, God, I don't know if I can even simplify that fraction, because sometimes you can't, then that might be a little trick you can do in the TI-84. So it's a nice little thing, right? Nice little trick. So now I'm going to try and use probability in a way to find evidence for something. And to kind of give you an idea, what we're going to do here is I've used it with my stats class and it's good data. So I want to use it again. And we're doing COVID. In particular, we're going to work at COVID data. Okay. We're going to answer these questions. What percentage of people in the USA have had COVID? Now, I don't mean die of it. I mean just caught it, right? And I need a percentage. And it's really just totally subjective. You could be miles off, but based on your own kind of gut feeling, right? What percentage of Americans do you think have had COVID and they've recovered or whatever, but they've had it?
3%.
I'll put people in this. Say that number again, Jed.
3%. The
3?
media is a lie.
Well, we'll find out. I'm going to get you some good data and we'll look at that. I'm not saying that the media doesn't like us. They do, but we'll find out what the truth is in a minute. And then you can compare it against what the media has told you, whatever that media means. Tara, what do you think? Give me a number. Based on your experience, what percentage of people do you think have had COVID?
I have no idea. Do you just want me to give you a random percentage?
Yeah, I got feeling or a guess. If you have no idea, I guess a guess.
I don't know. I'll say 25%.
So you think a quarter of Americans have had COVID? Okay. Who have I got in my picture that I can see? Kayla, you got an idea? A gut feeling? You know, I know 100 people and 20 of them have had COVID. You know, that kind of way of looking at it.
I think 3% is too low and 25 is too high. So I'm going to go with 12%.
I was going to say 15.
Okay, Kayla. And you were going to say 15? Okay. Would you agree that these numbers are pretty much all over the place? Because if you don't have data and you've never read an article that's a good article and not propaganda from whatever side is trying to convince you that they're right and the other people are always wrong, which is bad data typically when they do that, is it would be nice to get the real answer, wouldn't it? Right, just so that we can do it. So you might say, well, oh, well, how do I know that Mr. Robertson's not also giving me some skewed data because he has a political preference like every human being does? Well, you're just going to have to trust me in one sense, but I can assure you that the data I collected was good data, right? I didn't make it up and I didn't get it from other places. So I guess what we need to do is imagine how we can come up with this number, right? Whatever that number is going to be. Would you agree that since I'm going to do, what's the probability that you choose a person at random from America and they've had COVID? That it's going to consist of two numbers, agreed? Probabilities boil down to being two numbers. Shouldn't the bottom number be the total number of people in the United States of America, right? Because we're interested in percentage of Americans have it, correct, right? You're not really too interested in the percentage of Scottish people, right, or Chinese people or any other country. And shouldn't the top number then just be the number of confirmed COVID cases? So I really did quite a lot of hunting and I came across the latest data from the CDC. So we'll assume they are correct because it's the same DC that was counting the numbers when President Trump was in power. And it's the same CDC that are still collecting the numbers now it's President Biden, so I can't see that being distorted really. We would have known by now if it had been. And the total number of people who have had COVID is, well, I'll put this up here, not the total, the number of people who've had COVID. That goes on the top. Right, from the CDC, the number that's had it, and I'm rounding off the numbers only to make calculations easier, for no other reason. If you want to know the full figure, it was 32,151,152 as of the end of last month. But we can call that 32 million, right? And the population of America, I have rounded it off to 330 million. If you really want to know what the real number is, at least where I got it from, it's 329,800,000. So that's not me cheating. Would you agree it's just rounding off to make life easy? That, how many have got COVID? All the people in America. Would you say that's how you would calculate this number? And we're going to see which one of these, if any, it's the best. And I've lost my calculator. So here's my calculator. I'm going to turn it into percentages. In my mind, percentages are the easiest to get your head around. And the answer I have got is 0.097. Then you multiply that by 100. I should have done that earlier. You have 9.7%. So just a little bit shy of 10%. So if you have 100 friends and family, about 1 in 10 of them will have had COVID. Now, that doesn't mean everybody, it works out perfect. You know the way these things are. Some families, a lot of you had COVID, and other families, nobody, right? I'll give you an example. Most of my family are in Scotland, so that's a little bit distorted data. But nobody in my family, including me, have got COVID. And you know, I've got a huge family. I mean, we are talking scarily big, and nobody has caught COVID. My wife's family, I'm scanning through my brain here in case I make a mistake here. No one I know of in my wife's family has had COVID. Now, there's people in this class, and I don't want them to volunteer information if uncomfortable. They may be able to say, there's only 4 in my family and 2 of us had had COVID, you know, that happens as well. But on average, about 10%. Does that number seem about right? Bigger than you thought it was going to be? Less? After watching the news and internet stories and all the other stories, does that number seem where you're getting your information, were they making it seem that the real number was much bigger, or were they minimizing it and making it seem like it was a lot less? Because that might give you an idea of wherever you're getting your information from, if it's not pretty close to that figure, maybe you're getting biased information. Well, that's one probability, about 10% at random. Now we got the second one. What's the probability that you die from COVID? And this is where I think it's called optics in the political world. This is where you can take the same piece of information and calculate it in 2 different ways, both of which are valid, but can sometimes give you a different impression. So we need to know what 2 numbers to use. And I'm saying there's 2 different guys in town. And you might think, well, how can that work? Well, first I have to tell you, for America, how many of us have actually died of COVID. And the best data I can get is 540,720. That's the most up-to-date number I could find who've died of COVID. And I do remember there was a headline a way back, you know, 500,000 dead. Can you kind of remember that story? Whenever, so that, it looks valid. It looks reasonable at least. And there's 2 different ways of calculating that. So let's do the first one. On the top, the number who die, and on the bottom, I'm going to get the population of all America, and that's going to be. Can I call that 0.54 million? So that I can put on the bottom 330 million. Is that okay to convert that to a decimal, just to make it easier to press buttons? Are you okay? That's 0.54 million, right? That's basically 540,000. And this time I'm going to hit the percentage button. 0.54 divided by 330 times 100. And the answer is 0.16%. So the percentage of all Americans who have died of COVID is 0.16%. What do you think about that number? Does that seem small or big? Any feelings about that? Was it a surprise to you, the size of that number? Whatever direction surprise went.
It's a large number given. I'm sorry. It's a large number given other diseases in the past, but that's false. They predicted at the beginning of this onset that the fatality rate would be 0.01 to 0.02%.
Well, they got that wrong then. So that's a larger fatality rate than where you've been getting your information said was going to happen. And I'm not saying that you got it from some guy in a I mean, it could easily have been MSN or Fox News or CBS or NBC or whoever it was, right? Right, and so that was what they were pushing. Now, I said there's two ways of counting that. That's the percentage of all Americans who will die of COVID. Or there's going to be some more dying, so it'll increase. But that's what it is right now. How do I come up with the second way of doing it? Well, the top number has to be the number who die, right? But what do you think I'm going to use for my second bottom number?
The amount of people who actually tested positive with COVID.
Yeah, the number of people who had COVID. Well, tested positive is probably a better way to say it, right? And if you take that answer, it's 0.54. And the number who've actually had COVID is about 32 million. And when we do it that way, 0.54 divided by 32 million, then you times that by 100, we are looking at 1.68. Let's just call it 1.7%. Now, both of those numbers are true, valid, and correct answers to the percentage of the population who have COVID, but they are not the same number, clearly. In a lot of ways, isn't this 10 times bigger than that? So if people are saying the death rate is 1.7%, they are using this number. And if they say the death rate is only 0.16%, you realize they're using this number. Aren't both of those measurements of death rate? The question is one of them better than the other? Is one more realistic? Because if you are wanting to get across a certain point, won't you use this one instead of that, or that one instead of this? Can you see how the number that you tell people can be because of how you're trying to influence them, right? If I'm trying to worry you and get you to do everything I want you to do, because I don't want you to die COVID or whatever reason, won't I probably be pushing this number and saying that the death rate from COVID is 1.7%? And that gets you, oh, I don't feel good about that. I better do everything they tell me. And if I'm trying to minimize it, I might use the death rate as 0.16%. Now, they're both correct, but they're different versions of correct. And so when you see people telling you stuff, will you try and say to yourself, what's the top number and what's the bottom number? Because that might give you a better idea of the reality of it. Now, no matter how you look at it, 500,000 people plus dying is not good, right? That is just not good news. It's a lot higher than the flu. So I collected data on the flu. Do you know, in a typical year, 61,000 people die if it's a bad year, and 22,000 people die if it's a good year. Which, as far as percentages go, is about, COVID's about 12 times more deadly than the flu. Right? People die of the flu, but COVID is about 12 times more deadly. Now, I like this data so much that I collected some other data, because I was always, COVID's been bugging me and I wanted to get a little bit of depth in it. So probability is the way I do things when I want to get, to me, if I want to get the truth, I need numbers and I need facts. I don't need opinions or explanations, because very clever people can tell me stuff in such a reasonable way that I would agree with them without mentioning a number anywhere. And I've kind of learnt that lesson. So if you say something, I want to ask, prove it to me. So this is me using data, and we are going to do Washington State. 9.7% of Americans have caught COVID, but it's not the same in every state. Do you think Washington is typical, so it's going to be about 9%? Do you think Washington State is worse than that or better than that? What do you think our state is? Same, better, or worse? What's your gut feeling?
I know we were worse to begin with, but I don't know if
Okay.
we might be doing
What
better.
now? Okay. Hey, I've got a time. I'm going to do it as a general vote. Do you know the little thumb thing? That guy. Okay. Let's do a quick head count. How many think that Washington State is worse than the American average, which is 9.7% COVID rate? Stick a little thumb up if you think Washington's worse. 1, 2, about 3 of you. Okay. Let them disappear. Set your thumb up now if you think actually Washington is better than the national average. In other words, we have less COVID. 1, 2, 3, 4, 5, 6, 7. 7. So I'll say that the rest are either undecided, didn't want to vote, or whatever. And what have we got? 2, 4, 5, 10, 15. Oh, great, 25, a really nice number. Right, so we're looking at 5. Was that 5 in that? Better not risk it. 60% think it's about the national average or didn't vote. About 28% are going that way. So that leaves 12% to go that way. So I've forgotten which one. Was that worse or better? Can you remember what the first vote was? The 3?
I think that was better.
Right. So we think Washington's actually better, meaning less COVID. 7 of us thinks that it's worse than the national average, and the rest think it's about the same, right? Give or take a little. Now, that opinion is just basically based on watching the news and finding out, what Washington State's looking like and surges and so on. So here is the raw data for us.
Excuse me, can we see
Yes.
what you are writing, please?
You would like that, wouldn't you? And I forgot to do all that. There we go.
Yeah, thank you very much.
So here is the data I've just collected. So let's figure out then, what's the probability, right? You pick somebody in Washington State and they've had COVID. And that one you don't really need to, there's only really one real version of that. And the data I got, the most accurate data I could find at least, is that, I'm going to use the full number here, that 397,417 people in Washington State have caught COVID. Have been confirmed COVID.
I think
Let's
the
phrase it that
numbers
way.
are the other way around.
What, these two? You think that's
The
worse and
better
this
and
is better?
worse, yeah.
Okay. Okay, so let's find out if they're right. I didn't really round these off. I guess I could have, but I didn't. So these are the pure data. 397,414 divided by 7,600,000. And the answer that we get is 5.2%. Very, very roughly, about half the rate. Does that surprise any of you? No? Actually, that's pretty good, because I've did this with other stats class and I was kind of happy. I'm thinking, oh, and that means we're in a state where we have, we still have tons of COVID cases, right? But we're in a state that's about half the national average. So there's probably going to be some horrible states that are much bigger. Because, if there's some above an average, doesn't have to be some below the average, so the average is the average. What's the probability that you die of COVID? Now, I don't want to do both versions, although I could. So which one of these two do you want me to do? The percentage who die compared to the entire number of people, or the percentage who die compared to those who had COVID? Because there's No, there's two versions of this.
Those who had COVID.
Right, so we're looking at this number here, right? Which will be larger because of that. So the number in Washington State who actually died of COVID was 5,448. And the number of people who had confirmed cases is that. So in other words, 5,000 out of that, 394,000 died with COVID. So 5,448 divided by 397,414. And the answer came out about roughly, I haven't multiplied that by 100, but it's basically 1.4%. So fewer people and a slightly better death rate, right? Smaller, I'm sure, means better. And you could go into why. And sometimes it's just geographical, isn't it? I mean, when you look into how people die of COVID, what are the main factors? Age is a factor. Don't get COVID when you're 80, because you are much more likely to die than if you're 18. In fact, do you know the number of people who die with COVID when they're 18 is almost negligible? It really is. So, Lee, don't worry about catching COVID. If you catch it, you're fine. Now, not wishing bad luck on you, but the probability says that you're pretty safe. The people who do die at that age, and there are people who die at every age, tend to fall into two categories. The first one is what they call underlying medical conditions. And the worst ones for COVID are anything to do with breathing. So don't be a chronic asthma sufferer, right? Anything to do with pneumonia, weak lungs, anything that's bad with COVID. And the other one, strangely enough, is connected to obesity and heart rate. So don't be overweight and have a weak heart. But if you're 18, that's the health one. What's the second reason? Really bad luck. The healthiest people in the world die of all sorts of weird things. Do you know there's joggers who died of the flu last year? 18-year-old healthy people caught the flu and died. Right? That's just life. No particular, just bad luck. But don't have the underlying. So that's Washington State. We're quite a good state, actually. Out of the ones I looked at, do you know we're actually the best state? Now, that doesn't mean that there's not other states. I didn't look at all 50 of them or whatever you've got. I think it's 50 in America. Right. I have a number of states to do a comparison to. So that's a very good one. Texas, New York, or Florida? Which one do you want me to do as our second version of this? Texas got the job. Now, I told you that that's the best. So Texas is going to be worse than this, right? Might not be much worse. Do you think Texas is going to be close to the national average, which is 9.7? What do you think? Better, worse, or the same?
I say worse.
Better. Worse. Okay. So let's find out. Probability that you have COVID in Texas. Well, the data that we have got in Texas is that there were, try and get this number, 2.9 million. Because Texas is so big, I can go back into millions again. 2.9 million. Oh, I forgot to check that. There are 29 million Texans if you do it to the nearest whole number. And I don't need a calculator for this one. The answer is 10%. And the national average was 9.7%. So Texas is what? Just a little bit bigger than the national average, but only 0.3. Now, what about the percentage who die? Well, we're going to use the same rule that we did with Washington State. So I'm treating like with like. So if we look at the population who died, and in Texas, how many died? Oh, I have to go big numbers again. So it's going to be 48,973 million died out of 2,860,489. And if you're wondering where I got that data from, I got it from the census data from the American side. So it's pretty accurate. And let's see what that ends up being. 48,973 divided by 2,860,489. And then you put those guys together and it ends up being 1.7%. And that is higher than Washington State again. And exactly the same as the national average. So if I kind of put them together, Texas is 0.3% higher, which is higher, but it's not significantly higher, and about the same percentage die. In fact, all the ones that I'm not doing, see this number here, the percentage who died, in this case it was 1.7 for Texas. I'm trying to find the other versions. For Washington State, it was 1.4%. If you're interested in the other two, it was 1.6% and 1.9%. These are the percentages who die who had COVID. When you look at these numbers, okay, they do differ a lot, but would you agree that they're at least in the same ballpark figure? They're 1 point something. Some are a little bit higher, 1.9, some are a little bit lower, 1.4s, but they're all in that same ballpark figure. And the reason, well, my explanation for that is it really doesn't matter how you got COVID. Don't about the same percentage of you die who get it. Right. So if a state has twice as many COVID cases, the same percentage are going to die, give or take a little. Which is, I think that's probably a reflection of, with some variations, isn't the American health service pretty consistent throughout America? That was, for me, I think that a very interesting little project to do, and it did use statistics. So I'm going to do one minor little project, and then we'll be doing expected value. And this one is did you know that Seattle hates Scots people? Oh, by the way, it's a made up headline, right? Seattle hates Scots people. And imagine you read this article on wherever it is you read things, and you look at it and you think, oh, they don't like Scottish people. How do you mean? It says, well, in particular, it's the police who don't like us. You didn't know that. And what they did is 2% of Seattle's police are of Scottish ancestry. That is tiny. They don't like Scottish people. They won't hire them to be in the police force, for starters. Evil police force in Seattle. That headline has a number in it, and I'll assume that that number is true. So why can you not make the assumption that that's evidence of anything? Because actually it's not evidence of anything. What's missing from this story?
The total amount of police.
The total amount of Scottish people in Seattle.
Yes, that's a better number, but total number of police could be connected to that. If I told you that when you factored in how many Scots people lived in Seattle, and you divided it by the number of people who lived in Seattle, and the answer was that 2% of Seattle is Scottish. Isn't that number exactly what you would have expected to be in the police force? Right? If 2% of everybody in Seattle is Scottish, and the police force is a representation of the people who live there, shouldn't only about 2% of the police force be Scottish? And that seems a reasonable number. So in that case, this is nothing at all, right? There's no evidence to prove in. Suppose I went and said to you, pretend that wasn't what I got. Suppose I found out that 10% of Seattle was Scottish. Right, 1 in 10 people in Seattle is Scottish, but only 2% of the police force is Scottish. What would that be evidence of? %10 of Seattle is Scottish, but only 2% of the police force is Scottish. What might that be evidence of?
Not very many Scottish police officers.
Right, and that could be because Scottish people don't like being policemen. I guess that's a possibility. Or Seattle doesn't like Scots people, so they don't hire them in the same numbers that they should other groups, right? But there's some kind of bias going on. Either it's Seattle police that's got the bias, or Scottish people don't like being policemen, right? And that's the bias, policewomen, right? And here's a silly one, but it could happen. 0.5% of Seattle, right, are Scottish people. But 2% of the police force are Scottish. In a way, isn't that the exact opposite of biasness? Isn't that you're favouring Scottish people? And I don't know if this is true today, but wasn't there cities in America that had Irish policemen? So if you went to Boston, the policemen were just Irish. It was like Irish people got a job in the police. You know, it was like that kind of favoritism kind of thing. Maybe something like that was going on here. But the gist of this question is, do not use raw data and think it's telling you anything. Right, a single percentage doesn't tell me enough to make any conclusions. Don't you kind of have to know some more stuff? And if you see something online or you see something in the news, maybe you should look at it a little bit more skeptically and say, is that number telling me the whole truth and nothing but the truth? Or do I need to know some more before I can make that judgment call? Because, I mean, superficially, that could certainly make you think something, but in reality, couldn't it be one of 3 totally different stories? And that lack of information is scarily common in a lot of the stuff I see nowadays. I hear generalizations, but they don't tell me the numbers I need to know. And if they don't tell me the numbers I need to know, work on the assumption that they're lying to you, because you'll be right more often than you're wrong, in my opinion. Okay, we are ready for our next topic, and I've written it down somewhere, so here we go. Do we need a joke just to kind of balance the first from the second? No? Okay. This one is going to be on what's called expected value. Yes, that's what I call it. Actually, they call it that sometimes, and then they call it something else the rest of the time. Okay. What this calculation called expected value does is it puts a number on typically gambling and what you might or might not win in any particular gambling situation. So here is a simple, we'll start with the simplest situation. There's only one winning outcome. So what do these situations look like? First thing is a free draw. So it might be, go to this website, you don't need to buy our product, put in your email address and you're automatically entered for a $1 million first prize. Now, the thing we call expected value, I think they also call it expected number or something else, but the word expected will be in all of them, is the amount you win times the probability that you win. So let's return to that story about $1 million draw. Right. So you go into the website, you type in your email address and you go submit, and they'll probably have some things at the bottom that says only one drawing per person, right? That kind of thing. So you don't just keep hitting it, you know, 1 million times. So let's suppose they do that and 33 million people sign up. The expected value is how much you win, which is 1 million, multiplied by the probability that you win. Right, now what's the probability you win? Probability has got two numbers. Okay, 33 million people took part in this free drawing. You are just one of them, right? You're only one shot. And 33 million go in the bottom. And the expected value for this particular storyline is 1 million times, put a bracket around it, 1 divided by 33 million. And the answer I get, and it's money, is dollars, is basically this. This particular gambling situation, this free draw, has got an expected value of positive 3 cents, which means if you take part in this competition, if you spread all the winnings amongst everybody who took part, which is another way of looking at it, it's very low, it's 3 cents. Let's pretend it's Pepsi who did this. Actually, I should tell them they might do it and I could get some money. Why on earth would Pepsi give away $1 million? I mean, what's in it for them?
If to enter, you had to buy a bottle of their soda to get.
Well, that would stop it being free, but yeah, that's not a bad idea. Actually, I would put that in, but
More
don't they
publicity.
get publicity? Yeah, don't they get name recognition? I bet you when you go to that site, if it existed, wouldn't it be full of advertisements and maybe even click this box to buy, you know, a dozen cans of Pepsi or whatever, right? Or these are your local stores that sell it, or, you know, all that stuff. And $1 million might seem a lot to you, but you know, in the big advertising world for huge companies like Pepsi, isn't it just a drop in the ocean? Right? I mean, they used to do it. I don't know if they still do it. Did they do that thing where in the underneath of the cap there's a number, and if you typed it in, sometimes you could win things? Do you know what I'm talking about? It's the same kind of thing, right? What that got is it got them recognition. So can you imagine what the headlines, wouldn't that be in the news? Pepsi's giving away $1 million free. Right? And do you know, secondly, because of the way I did it, didn't I get your email? And what do you think they're going to do with that email?
Advertisements.
Aren't you going to get in? And yeah, aren't you going to bombarded with anything and everything that Pepsi makes?
On top of that, when
So
they're done,
in their way, look,
I'm
say
sorry,
that again.
on top of that, when they've wrung every bit of value of out of your email that they can, they'll sell to somebody else.
Yeah, and emails are worth money. You know, if Pepsi got 1 million emails, so actually they got 33 million according to my story. Do you know how much that would be worth to an advertising company? I mean, it's almost, well, I know they have rules about what you can, but normally they get you in the small print. You have to agree to this and you have to agree to that if you want to take part, you know, that kind of thing. So you sign your life away for what, 3 cents money? Okay, here's a small one. Same story. It's a free draw. This one's in a local shop. So they're going to have one winner and it's $100. Yeah, because it's a small shop, they can't give away 1 million, right? And well, they do it different ways. Don't you take the receipt and you write your name on it? You know, Janice Smith and maybe a phone number or something. And there's a little box and you slip it. Have you ever seen the places where you do that and you slip it in and you get something, right? That's how they would probably do it. Very low tech. What's the expected value of this going to be? Well, it depends on how many take part. So let's say in this particular one, 200 people, right? Bother to fill it in. So your expected value is going to be the amount you win multiplied by the probability that you win. And you're going to win $100. There are only one of you, but there are only 200 people who took part. And that ends up being, I don't need to calculate that. That ends up being 50 cents. Now, according to probability, because this is using probability, if you could only take part in one of these two competitions, wouldn't you be better to take part in the local shop one? You won't win a fortune, but won't you have a great chance of maybe winning at least something? In this question here, aren't there going to be 32,999,999 losers and one winner? And in this case, there's going to be only 199 losers and one winner. So if you are looking at competitions, one of the ways of deciding the risk benefit to them is to find this special number called the expected value. A big expected value is a situation where you're likely to win something more often than any of the others. Right? It's a good competition to take part in. It doesn't mean you'll be a millionaire. Now, optimists amongst you would say, why bother? At least if I win, I'm a millionaire, right? Which is what people do when they do the lottery. But in the lottery, don't you have to pay money?
Yeah, taxes.
And taxes after you win, but only after you win. So let's show you how you do expected value on things like lotteries, right? So this is, let's have a lottery and I'll keep the number simple. There's a $2 million first prize. I know most lotteries have a second, third, fourth, and fifth prize, and I will eventually get to those situations. But I just want to keep it, you know, simple before we get complex. So in this lottery, it's a $2 million first prize, okay? But there's a ticket, and it costs you $5 per ticket. But you can buy as many tickets as you want, I guess, right? But to keep this story simple, you're only going to buy one. Now, if you say, well, what happens if I buy 10 tickets? Do you know all you do if you buy 10 tickets is you make this number 10 times bigger. So it's easy to factor that in if you wanted to. So how do we adapt the expected value? Well, it's the amount you win times the probability that you win minus the amount you lose times the probability that you lose. Why is that negative? Why do you think you subtract what you lose from what you win?
Because
Why would that
maybe how
kinda
many
make
times
sense?
you tried but lost.
Yeah. I mean, couldn't you just buy 12 million lottery tickets, in which case, even if you won, which you probably should, wouldn't you still be down on the day because you spent more money to win than you did winning, right? So negative does make sense. Now, in this story, you're going to win $2 million. That's a good chunk. And since I'm doing a one ticket story, right, we need to know one more number. And that's how many people took part in the competition. Because if only one person took part in the competition, I wish it was me, because I'm going to win, I guess. We'll make the assumption they keep drawing numbers until they get a winning number, right? So it's a one deal thing. I know in reality, don't they, if nobody wins, it just gets taken over to the next week and it just gets added to, right? But for the sake of this one, it's a 2 million lottery. Someone has got to win it, right? That'll be the big advertisement. So they bring out the numbers and the computer checks all the numbers, right? It's not done by hand. And the computer will say, no, nobody there. They do it again, nobody there. Ah, somebody won, right? So let's say in this story, there was 3 million tickets sold. Do you think the company that's winning this lottery are onto a moneymaker? Just looking at the data before we've calculated anything. Okay, how much money is this company going to take in, this lottery company? See it? 3 million tickets at $5 each. They're taking in how much? $15 million? What are they paying out? Okay, there's expenses and things, but would you agree it's a moneymaker, right? Have you ever heard of a lottery company going bust? Most of them are done by states, so they never go bust. Can you see why they never go bust? Okay, back to our question. The probability that you win is one ticket out of the 3 million that were cast. Take away the amount you lose times the probability that you lose. Okay, let me talk about the probability that you lose. Are you comfortable with the 299,000 over 3 million, right? You can only win one way, and there's 299 million other ways, ways to not win, right? The only number that's missing is the one that goes here. What number do I put in this where my finger is?
That'd be 5.
Yeah, because this is a $5 ticket, right? That's what I lose. And let's see what the net result of this is. Okay, I'll try and do it in one go, even if it doesn't fit in the screen. It's 2 million times 1 divided by 3 million. That's that guy. Take away 5 times 2, 1, 2, 3, 4, 5, 6, divided by 3, 1, 2, 3, 4, 5, 6. Roughly. No, that is not a mistake. It is negative. What do you think a negative expected value tells you about the gambling situation you've just entered into? You're going to lose money more often than you win, right? So it doesn't mean that when you play the lottery, they then, you know, give you some of your money back, right? It's just the big picture thing. That is bad news, right? And the bigger that is it that the worse bad news is? Because it means, yeah, you're going to lose, and you're really, really going to lose pretty much every time. If you played it for the next eternity, you're probably still not going to win. You know, it's kind of stacked against you. Pretty much every lottery I know is a negative number. And the only time, and it's very rare, but it does happen with the rollovers. Have you ever seen a rollover one where it's some ridiculous number like 120 million? In that one instant, you could actually have a plus for the expected value, because you could imagine this number being 120 million, right? Everything else stays put, right? Your chances of winning are maybe the same, right? Your chances of losing are the same. Your bet's the same. But if this number gets bigger, can you see that that could change over and become a plus? It's very rare, but it does happen. So I guess the advice I would give people, don't play the lottery until it's a rollover, and only do it when it's a rollover that's extremely big, and not everybody and their mother has bought a ticket for it. Because if that number gets big, doesn't it cancel that number getting big? And so you're in the same boat. So there's a sweet point that sometimes happens. Do you feel like I'm telling you how to gamble here? I'm not telling you how to gamble. Basically, gambling is a totally bad idea.
Yes, but
That's
I need
why
to know what
Vegas
the
is
rollover is, because my boyfriend was just suggesting that we get lottery tickets, and I was like, no. So I'll tell him only if it's the rollover.
Right.
My professor said. We did the math.
I qualified that with, and not everybody and their mother is also in that lottery. So you have to sometimes look and find out the article, because the article might say something like, this Tuesday's lottery is $100 million and 8 million tickets are already being sold for it, you know? And if you know those numbers, plug it in here. If the answer is positive, it's a good bet. You still won't win, because you know there's 40 million people going to lose and you're probably one of them, right? But probability says it's a good bet. Sometimes, just sometimes, you do a gambling thing and the expected value is 0. What does that tell you about the gambling game? If you kept on playing it over and over and over again, you'd win sometimes, right? And you'd lose sometimes. But what the net effect would be, you'd break even, right? And when that happens, we call this a fair game. When the expected value is positive, you will win eventually. In other words, you will win and make more money than you spent on average. Not every single human being will be able to do that, but on average, you will win eventually. And when the expected value is negative, you will lose eventually. Actually, you probably lose right away, because in all of these, you tend to lose more often than you win. The trick is that you tend to win more money than you gamble, right? Would anybody here in their right mind take part in a $5 lottery if the winning ticket was $4? I mean, it's stupid, isn't it? You have to win more than $5, right? And it has to be a noticeable amount or people wouldn't bet it. Are we good? Any questions before I move on to the next level, which is a little bit more complicated? Last chance? Okay. Still expected value. The whole thing is about expected value. Here's my my next one. Right. I'll do it as a spinner. Can you pretend I can draw spinners and A, B, and C are the same size? Right. Now, you're at a, I don't know if you're allowed to do in America, you're allowed to do it in Britain. Do you know that you're allowed to do miniature gambling things for charity, you know, shows and organizations and school fetes and all the kind of things that you might do as a community? Are you allowed to do any even miniature gambling things in America? And it's maybe in some states, yes or no. Okay, in Scotland, you can do this. So you buy a ticket, and the you buy an A, a B, or a C. It doesn't matter what you buy. And lots of people can buy their ticket. And try to think of how this works. Yes. So you buy your ticket. And it's going to cost you, it doesn't really matter for the story. Let's do it as a $10 ticket. So you're not going to buy many of them, right? $10. And if the little counter stops on A, you get $5. And it stops on B, you get $7. And if it stops on C, you get $15. So you get paid back something, no matter what you right? So you get your ticket, and then it's a big circle, right? And they give it a twirl, and off it goes, and then it stops. And if the counter stops at A, you get $5 back. You don't get your money back. They just give you a compensation prize of 5. And if it's a B, you get a 7. And if it's a C, you get 15. Do you think this game is a fair game? In which case, you're going to get a 0 expected value. Do you think this game is positive? In other words, the school's screwed up because they're going to end up paying out more money than they take in? Or do you think it's a negative one where you, the person who's gambling, will lose more than they win eventually? What's your gut feeling about this combination here?
I think that they're still going to make money. That's the idea, is that they make money.
We would hope that it would make money, right? Let's find out if they. So if you're in charge of one of these, wouldn't it be a good idea for you to do this calculation, right? So that you don't end up, hey, how come we lost 20,000 in that charity wheel that you said we could make some money on? Yeah, that would not be a good way to start your career. So expected value. Now, since this is like the ultimate version of the other ones that we've done, it's still going to have the same format. It's just going to have more formats. So in this one, it's going to be the amount you win if A comes up, right, times the probability of A, plus the amount you win if B comes up, times the probability of B, plus the amount you're going to win if C comes up, times the probability of C, right? Now, you can't lose in this situation, right? Because it's going to stop on something. But we still have to factor in one piece of information that I haven't got here. Doesn't the ticket cost you $10? So where in this formula am I going to stick the $10 that you pay? Where would you think I should stick it? This is kind of what you would win. Take away 10. Okay. what you win, take away your $10 bet, right? It's very tiny. And do you see you want it at the end, because if the answer's negative, don't you lose money? So you should be trying to subtract the general amount you win minus 10. So let's see what we get here. The amount that you win is $5. Chances of it happening is a third. For B, the amount you win is $7. Probability of that happening is a third. For C, the amount you win is going to be $15 times the answer is a third. Take away your $10 bet. And let's see what that ends up being. I think I'll keep it as thirds. So that's 5 plus 7 plus 15 thirds. Take away $10. That's 27 thirds. Take away $10. This was a fluke. I did not make this happen, but I'm pleased it did. That is negative $1. In the long term, every time you play this game, you take $1. The way the people who run this will look at it, every person that bets, on average, they're taking $1 off them. So can you imagine if there were 100 people betting every spin, they'll probably on average take $100 out. Next spin, another 100 win. Next spin, another 100. There won't always be 100 because probability doesn't work that way. Can you imagine there are going to be lots of situations where it hits A maybe a little bit too many times and it hits C maybe not quite as many. Right. But the long term, this is always based on long term. This game is in favor of the owners of the game. You're going to lose $1. If you gambled 100 times, wouldn't you lose $100? At $1 each time. You like that one? Right. Do a different spinner. You got the spinner, round and round it goes, where it stops, nobody knows. That's what they say when they do it. If you ever, you have never seen it yet. That's what they say when you spin
Never
these
seen
things.
anything.
Round and round it goes. You never heard
Never
that
heard,
little
I've
saying?
heard this one
Round and
before.
round. Okay. Round and round it goes, where it stops, nobody knows. It's what they do. Now, this is a $1 bet game. And this is, if it lands in any of these three, you win $5, $10, or $5. If it lands down here, you lose your money. What's your gut feeling telling you this time? Would this be a good game to bet in? Would it be a positive expected value? Say again?
I'm gonna say no because there's a pretty big chance it's gonna land on the last part because it's a bigger half.
It is. And when you win when it goes to the top, you do kind of win money, so maybe that compensates. Do you think it compensates enough? That's the question. Right, let's see how this one works. Expected value. Well, I won't call them ABC. We can do it. What's you win $5, right? Times the probability. I guess I should call them ABC. I'll make it easier to distinguish. Times the probability of A, or $10 times the probability of B, plus $5 times the probability of C, and take away $1 times the probability that you lose, which is D. So do you see in this question, it's 1 times the probability of a loss. What is the chances of you landing on each one of the A, B's, and C's. They're meant to be the same size. And it's not a quarter. And it's not a third. What's the chance that the little spinner stops on A?
Is it a sixth?
It is. Do you want to maybe explain what made you think of that? It is a sixth. Why is it a sixth? I see a nod now. If I add some invisible lines in, can you see that's 3 6 and everybody else is 1? Does that help? Well, let's see what you get here. 5 6 plus 10 6 plus 5 6. Take away a half. 20 over 6, take away a half. That's going to be some really ugly fraction. So I'll turn it into a decimal, I think. 20 divided by 6, take away a half. And the answer I get is 2.83 roughly. Wow. Positive number. This is definitely in favour of you, isn't it? The gambler. It's in favour of the gambler. Do you know that there is no game that I know of in Vegas, a real game in Vegas, run a promotional stunt, that has a positive expected value? Every single gambling game in Vegas has a negative expected value. If they create a new game, whether it's a card game or a dice game or whatever that game is, before it becomes out there for people to take part in, they figure out its expected value. And if it's not negative, they will not do it. Because if it was positive as it is here, wouldn't you actually pay out money? You'd lose money in the long run. I'm not doing the calculation. Suppose I made that a $10 bet. Wouldn't that change the game? You had to bet $10 to take part. Can you trust me, if you bet $10, this becomes a negative number and now it's in favour of the house, as we call it, right? The house is, Vegas, and you're the gambler, right? So you're a gambler and the house is the people you play against. Do we like these guys? It's a little bit different. Okay, so what I'm going to do now, if I can figure it out by closing enough windows and opening another one, is that we can look at the homework questions eventually. So this is 13.2 I'm looking at, or at least we'll all be looking at shortly. And there's still some things to do, but I think we've done enough to get a start. Right, here we go. Expected value, 13.2. Only 8 questions, very short section. A magazine subscription service is having a contest in which the prize is $40,000. If the company receives 1 million entries, what is the expectation? Oh, there's the word to use. Expected value is sometimes called expectation, right? Okay. In this story, would you agree this is the first one we did? It's a free draw. In this case here, won't it be 40,000, the amount you would win, times 1 over 1 million? We'll assume that you're not allowed to do multiple entries, right? 1 per customer. So 40,000 times 1 over 1 million do not be surprised if that's some ridiculous like 0.02 cents, right? Technically speaking, this isn't a free draw. Gesundheit. This is not a free draw. Don't you have to be in a magazine subscription service? So it's not open to the general public. I can't remember what the first name is, but isn't there a thing called something clearinghouse that you see advertised on TV where they guarantee you things like $50,000 per month for life? You ever seen that guy? Just me? I believe they're a magazine subscription service, right? You pay so much a month and you pick from a list of magazines and they send them to you. A box contains one of each of these, a 1, a 5, a 10, a 20, and 100. You reach in and withdraw 1 bill. Now, this is another free draw, isn't it? You're not forking out any money. The guy just says, I like you or whatever. Here, stick your hand in here. Whatever number comes out is going to be yours. Now, I know the wins are going to be 1, 5, 10, 20, and 100. What are the probabilities going to be for each one of those? So for instance, a $100 bill is going to be 100 times the probability that you win that number. What is the probability that you win the $100 bill when you stick your hand in? Well, how many things could you pull out? Right. Well, assume it's a bit of paper and it's a note, right? And you pull it out and, oh, I've got a $5 bill, right? There's only 5 of them, isn't there? We'll assume there's one of each. So a $100 bill, won't you get that times 185 times a fifth? Does that make sense? Right. There's too much words here and not enough sense. So let me set the question up, show you what I'm trying to get across. So in this story, it's a free story. You can win 1, 5, 10, 20, or 100. And the expected value will be $1 times the probability that you pick that guy up, right? You win $1 plus all the others. So there are 1, 2, 3, 4, 5 things that you could pick out. So it's that guy. You could win a $5. That'll happen 185 times. Or you could win $10. That will also win 185 times. Or you could do a $20 185 times. Or lastly, you could win $100 and that's 185 times. So here goes. I'll just call them all fifths. That's a quick way of doing it. 1 plus 5 plus 10 plus 20 plus 100. So it's 136.85. And 27.20. That is a good game to play, isn't it? Cost you nothing. And look at how high the expected value is. Now, I'm going to give you a choice. So you come up and the guy says, look, we've got 2 versions of this game. You can only play one of them. Which one do you want? You've got this version here, but we have another version. It's a little bit different. You got a $1, a $1, a $1, a $5, or a $200. Do you still want to play this game or do you want to play that one? What do you want to play? I think I'll take you off mute because I think some of you are trying to talk, but I can't hear you. No. Which one do you want to play? Do you want to play this game still? Or do you want to move on for this game?
First one.
Which one's going to be?
I would still.
You still like the
play the
first one? You're all going to play this one. You're not going to play this. Sounds like a. Well, how do we numerically check that, right? Well, let's see what the expected value is. The expected value for this one is 1 times a fifth plus 1 times a fifth plus 1 times a fifth, 5 times a fifth, and then $200 times a fifth. 1 plus 1 plus 1 plus 5 plus 200, 2, 5, 6, 7, 8, 208 over 5, $41. Why is this game a better game to play than this one? Although some of you were thinking this one is better. Were you looking at this one and saying, look, I can still win some good money, 5, 10, and 20? Whereas over here, but this one has a larger expected value. At least I counted it right, it does. What the heck's going on? Because it's counterintuitive for some of you. It looks like this is better than that, but actually the numbers say this game is better to bet on than that.
The first one, even if you don't win the $100, you're still winning either 1, 5, 10, or 20, while in the other one, your options are just 1s and 5s.
Right. But isn't the top prize, which you will win 1 out of 5 times, twice as big as the top prize here? So if you're a pessimist, you play this game because you never win the big one, right? And if you're an optimist, you might think that this was always the best bet. But what the numbers are telling us is that if you were playing this game over any length of period, this one would give you more winnings than this one. Okay, you'd win a lot of 1s, but when you now and again get some 200s, you'd win a lot of 1s and 5s and 10s, but even when you got a big one, it was nowhere near as good as that one. That was quite interesting insight, isn't it? That not all gambling games are equal, and sometimes what you think might be the best bet might not always be the best bet. This one, I'm not going to zoom back and forwards. I'll just tell you the story because it's not really a gambling one directly. Oh no, I changed my mind, too much writing. And I don't write well when I go fast. So let's just see this question, figure out what the heck's going on. I'm going to see if I can make it a little bit bigger. No, it goes off the screen. Okay. Suppose you have 10 quarters, 10 dimes, 10 nickels, and 15 pennies in your pocket. That's a lot of change. You reach in and choose a coin at random so that you can give it to your child. What is the expected value? What's the expectation? And round your answer off to 2 decimal places, which is, 0.12 for 12 cents. 10 quarters, 10 dimes, 10 nickels, and 15 pennies. So the expected value is going to be the value of the thing multiplied by the probability that it happened. So I'm going to just take the gist of that. So we are going to build an expected value out of this one. Okay. Okay. A quarter, that's 25 cents, right? Actually, okay. To keep them happy, because they want the answer to 2 decimal places, I'm going to change that into $0.25. Okay, now I need to know the probability that you get a quarter. Then I'm going to add a dime. Oh, shit, spice, why have I forgotten that one? A dime, 10 cents? I know it's a dumb question, but is it? I can't
Dime
see
is
any
10
heads moving
cents.
on it. Thank goodness for that. I never call them those things anyway. Probably that you get a dime. A nickel, that must be 5 cents. That's obvious. And the probability that you get a nickel, of course, 1 cent, and the probability that you get a penny. Does this question have a minus anything on it? Is there any cost to this? Does your child pay money to take part? No. So 0.25 times whatever that is, 10 cents times whatever the probability of that is, 5 cents times whatever the probability of that is, and 1 cent times whatever the probability. We need some probabilities now. 10 of these coins, 10 of these, 10 of these, and finally 15 of these. So what's that? 10, 20, 30, 40. There are 45 coins in your pocket. So the bottom number is going to be 45. If you want to know the probability that the coin you bring out as a quarter is going to be 10 out of 45. Dimes, 10 out of 45. Nickels, 10 out of 45. And pennies, 15 out of 45. That makes sense. You happy where these fractions are coming from the story? And then you just basically go to town with your calculator. If I screw, I hope somebody, at least a few of you are doing this with me, so if I screw up, you tell me. 0.25 times the first guy, plus 0.10 times the second guy, plus 0.05 times the third guy, and lastly 0.01 times the last guy. And it looks to me like 0.09. So what's that? It's about 9 cents. Did anybody get that same number? Can't see any nods, at least in mine. I'll go the full one. Maybe I can see some on the other side, because I have two sides with my pictures on. Nobody? I'm feeling lonely here, like I'm the only one hitting buttons. Did you get 9 cents?
I'm still writing everything. I don't know about everybody else, but I'm finding that if I don't make sure my
I'm
notes are pretty
completely lost,
thorough.
but it's okay.
I have a question.
That's what-
Okay, yes, go for it, please.
So if, let's say that was 0.098, would that be rounded to 10 cent
Yes, so you do
for this kind of
0.10.
problem?
Yeah.
Okay.
So if I caught her question, you do it on the calculator, and she said, what happens if it's, and I'm adding some extra digits in because that's what you get, right? In this case, that would round up. And so WebAssign would be looking for that, which is essentially 10 cents. If you want to think of what this number is telling me is, if you had lots of children or you did this every day, you would be on average forking out about 9 cents. So if you said to yourself, how much is that going to cost me in a year? You could do this. 9 cents, 365 days in a year, and we do it every single day. 0.09 times 365, and it would cost me about $32.85. So if you wanted to do this with your child and you did it every single day, and for some reason that's the same coins you kept in your pocket, we could project this into the future, and it would cost you about $32.85 to do it. Any questions about, any more questions about that? Are we good? Okay, let's move on. I'll try and slow down. I think I may be writing too much as well, which doesn't help. So the next question that I'm doing is similar to number 4. And I'll read out some of it, but I'll only write down what's important. In this particular story, Crinkle Potato Chips is having a lucky 7 sweepstake. There is one grand prize of $80,000. So there's one prize of $80,000. Okay. 7 second prizes. Each of these is worth $8,000 each. 77 third prizes. And each of these is worth $800. And God, this is going on forever. 777 fourth prizes. Each of these pays $80. What is the expectation of this contest? So we're going to get expected value. And we are told that there are 14 million entries. Now, they didn't mention in this story that you had to buy a ticket, so it's a free contest. So free contests by their very nature are going to have positive expected values, right? There isn't a cost to them. And I guess what we're trying to calculate here is what positive number it should be. So it's going to be 80,000 times the probability that you get first prize. Then it's going to be 8,000 times the probability that you get second prize. Then it's 800 times the probability that you get one of the third prizes. And lastly, it's $80 times the probability that you get the fourth prize. Well, I know what the 8,000 is. That's the easy part. And I know that there's going to be 14 million entries, so I know who the bottom number is. But what's your chances of winning out of 14,000 entries?
1.
Just 1. And this is 8,000. Still 14 million entries. But would you agree there's 7 of those? So it's a little bit more likely you might win a second prize, right? Of course, you have to keep going with this, right? For a fourth prize, no, a third prize, sorry, is 77, and I ran out of room, so I'll write it down here. And for a fourth prize, we get that guy. God in Himmel. I am not doing this on my own. I'm going to wait a few moments for you to catch up, and I am going to do it, and you are going to do it, and one of us is going to get the right answer, and I'm going to go up and get WebAssign to tell me the right answer, and so I'll know who's right and who's wrong. And no, I will not cheat. You'll see me hit the buttons. Now, it's to be rounded off to, you know, the nearest cent. So do everything as, you know, well, as you see it. So, a few more seconds. Okay, here goes. $80,000 times 1 divided by 14 million plus 8,000 times 7 divided by 14 million plus the 77 divided by 14 plus 80 times 777 divided by 14 million. Oh, that's kind of nice the way they lined up like that. And I have 0.0185, but to 2 decimal places, I have that. Did anybody get something different? Or the same even?
I got the same.
That's good. Like,
Bless you.
oh, excuse me.
Bless you.
Oh, that was 3. Oh, I am
You can always go for one
superstitious.
more.
Oh, I could go for quite a few more. Ask my wife; she tells me I sneeze. I don't like. Yes, the correct answer was the one I just gave. It listed 2 cents. I can't guarantee that bit, but this is what the book says. So basically, 2 cents a customer. You know, as an advertising ploy, it's not costing them much money, right? I think my $1 million. I think that's a good idea. I should tell them, shouldn't I? Here's an idea. It doesn't cost you that much. Here it's a +2. Well, do you know when you sneeze in Scotland, there's a poem for sneezing? 1's a wish, 2's a kiss, 3's a disappointment, 4's a letter, and 5's something better.
Oh no, I did not know that.
You never seen that?
No.
Ah.
Now I learned something new.
You're learning something every day. Something new every day. Not always statistics, but something new. Are we good?
Yep.
Right. Last question coming up for today. I'm going back to the counter. You spin the counter. If it lands on the +14, you win +4, I should say, you win $4. If it lands on this +17, you win $17. But if it lands on the -10 or the -5, that's how much money you pay. Right? Do you think this is a good gambling game? In other words, is its expected value positive?
I think it's more likely to win.
Okay, sounds like a plan. So let's find expected value, because that's essentially how we decide questions like this. So $4 times the probability that it lands on the 4. $17 times the probability that it lands on the 17. Take away $5 times the probability that it lands on the $5 mark, and take away $10 times the probability that it lands on the 10. Are you comfortable about why these two are negatives, but these two are positives? Does it make sense in the context of this game why that happened? Lose money, negatives. Win money, positives. What is the probability of every single one of these? Because they're all the same size, or they should be.
1 out of 4.
Yeah. And if you put them all into quarters, you get 4, you get 17, and you get these two guys. And it is, like you thought, it's a plus game. There are all sorts of versions of this game. I've never played it because it looks boring, but there's a game that they have in Vegas where it's lots of little pins, the little counter, and it stops. And I believe it's a $1 bet. And there's little slivers where different things happen. They're not all necessarily the same size, but in most of them they are. It goes on like that.
I know exactly what game you're talking about.
Okay. And in that game, there's always a kind of little skinny guy where you win out, say, I don't know, whatever it is, you win $100, right? Or 100 times your stake, you know, something like that, whatever the way they do it. And it looks very impressive, but that one sliver is such a small proportion of the wheel that it's still a negative game, right? This number is negative, so you lose. Because a lot of these, you don't win anything because it has to stop on the same one that you bet against. So there's a little list of what you bet, and I'm betting $1, it stops on the 5, or I'm betting it and it stops on the 100. Looks very boring to me. Does anyone know which game you should play, or what games you should play in Vegas to have, not, you're never going to win, but to have the smallest positive that the house would have? So what games are the best gamble? So your money lasts the longest.
I know 21 is a good one if you're good with
It
playing
is.
cards.
That's the best one. Blackjack. It's the best one I know. Roulette's a close second. Do you know the worst game to play? Any of the gambling machines. Do you know the ones that go ding, 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 and 4 bars appear and all that? Horrible, horrible percentages.
Gotta tell
I
that to my
love going to
grandma.
Vegas. Is that the one she loves? The ones that go ding, ding, ding?
Oh yeah, yeah. I was just, she always told me that's where you won't lose your money. That just makes me laugh a little bit now.
Yeah, I love Vegas. I think it's a cool place to go. Do you know what games I play? I play those ones, the ones with the worst odds, because there's bright lights and noises, and they go ding, ding, ding occasionally, and it's kind of fun.
Oh, see, I go.
I
for
do
the
not
card
go.
game.
I do not go there to win money. If I went there to win money, I would play blackjack. And
That's
I
where
still
I
wouldn't
won.
win money, but I wouldn't lose much. So again,
I said that's what I do. I played blackjack and I ended up winning. So
makes sense. Don't win all the time because you'll lose more than you win, but you'll lose very slowly, which is not
The
bad.
only game I ever go to play at Vegas is the bar.
Ah, yeah, that is.
can't really lose on that
I have
one.
been. Yeah, yeah. You can't argue on that one. That is definitely a lose-lose, but at least you get something for it. So you pay for your drink. Yeah, do you know you get putting you off here? Do you know in Vegas you get free drink? At least in most of the places you can get free
I
drink.
do, and I think you can carry them. At least I think on the strip you can carry a drink with you.
You can indeed. I've seen people do it. Scary what you can do in Vegas. Yes. So I don't know where that went to, but you could get drunk in Vegas and not buy your drink, but it'll cost you more money than if you just went to the bar and bought your own. So you're not saving money by gambling and getting free drink. And the only reason that I think they give you free drink is because drunk people are stupid. And so they gamble more. That's the only reason I can think they would do it. Okay, I think this is a nice time to finish this. When we come back the next time, we're just going to do some more spinner ones, similar to the one I've done, but we'll keep them until then. And that will be 2 of the 4 probabilities covered, and that's going to be everything you need for Sunday, right? So once we finish the last of this stuff, the stuff that's going to come after that, you don't need to do it for this Sunday, but you might want to, so that you have less homework the following Sunday when the midterm's going, because you want to kind of have that out the road so you can focus on just practicing for the final, for the midterm, I should say. Okay, say hi and bye-bye.
Mr. Robertson, would it be
Yes,
alright
who's
if I
talking?
just
Right, Gabe.
would it be alright if I just stayed
Say
back
again?
and asked a question? Would it be alright if I could stay back for
Sure.
a minute and ask a question about the homework? Thank you.
Perfect. Yes, do that.
I have a quick question for you.
Okay, go for it, Amelia.
I was wondering, I don't remember exactly, but you're able to be contacted like every day of the week, right? Like of the.
Correct. It's called Officer 10 a.m.
Okay, 10 a.m.
If you go into, if you go to Canvas, you'll find the Zoom link. You just click on it and wait. You know, it's a bit like knocking on my door. You may have to wait 10 minutes because I've got somebody else in the room, and you know.
Okay, yeah, I'm busy today, but tomorrow I'm probably gonna stop by because I have a couple questions myself too.
Perfect. Have a look on Canvas, because sometimes what's happened is that if it's a question I think is something a lot of people have trouble with, I put the solution online so you can actually look and say, that's the same one I was having trouble with, and it might cure your problem. Just a suggestion, it might not be the question you're having trouble with, but in case it is.
Okay, awesome, thank you.
Okay. Okay, Gabe, what you got for me?
Yeah, it's in 11.6, the amortization homework section.
That word, yeah.
Yeah. And then number 10. But it's gonna be different for you.
Yeah, but I can pick up yours because I can just go in. If you wait a few minutes, I can
I
do
imagine
that.
it's just gonna be like a formula that I just can't recall.
Well, yeah, so many of the darn things as well. It's hard to keep track of which one you're using. Normally, you just look at the thing. Clicking in this one. No, I shouldn't have been doing that. Let me click out of that one. I should be doing it under scores. That way I can find your question, Gabe.
Oh yeah. You can do that. I remember asking a question.
That way it'll be the same numbers that you're using. Right, here we go. Almost loaded up. Okay, it looks like it's going to be 7, 8, 9, 10, 11, right? Correct?
The ones I haven't done? Yeah. 7, 8, 9. It's from 7 to 14.
I bet it's 7 to the end or whatever.
Yes.
Okay. So what we really need to do is we need to find what formula you need to use, because if we get that one sorted out, then we should be fine. And do you want me to do number 10 specifically, or do you mind? Does it matter to you what one I do?
Yeah, number 10. And then I think I got it from there.
Okay.
Okay.
So number 10 says for a monthly payment for a Lone Ranger answer, it's a new car financing. Not sure that matters, but we'll put it in anyway. And the interest rate is 2.5%. And it's a 30-month payment loan down. And it's going to be 12,950. Does that sound a bit right for your numbers?
Yes, that's
making sure. Right.
Correct.
Okay. Okay. I am going to zoom into the ebook. Be too long. So the formula, oh, you can't see what mine did, sorry. Or maybe you could, I don't know. The formula is P equals M 1 plus R over N and negative NT. And on the bottom, an R over N. And let me double check on. Okay, make sure I'm doing the right numbers, right question. Find the monthly payments. Find the monthly payments. That's find M. Ah, okay, so I'm not using the right formula. This formula would be working the other way, but well, I could still use it. I would just switch places with those two, but there's a nicer version of that. So let me find what that would look like. If they don't, I'll do it the way I was going to do it, I guess. Oh, here we go. If you take this formula and rearrange it mathematically, you get this fella. Right, so how do I know it's this one and not that one? The question wanted to know the monthly payments. So the question was saying, find M. So I need the one that has an M in it. If the question had been, find the principal, right? Find out how much money I had at the end of this, then I'd be using this one, right? So now I have the correct formula. What I need to know is all the different numbers, right? All these R's and N's and put them in. So I guess I'll put them over here. P is the principal. In this case, it represents the loan. So 12,950. R is the interest rate, which is what, 2.5%. As a decimal. N is the number of payments, which is basically monthly. Right, monthly payments. Yeah. And time should be, and it will be, number of years. But it's not 4 years or 10 years or 2 years, it's 30 months. So they're just making my life awkward. And it's 30 over 12. Which if you do it is, I think it's 2.5, isn't it? Yeah. So yeah, it's essentially 2.5 years. Right. Now I've got all the numbers, it's plug and chug time. So 12,950, 0.025 over what? Over 12. 1 plus 0.025 over 12. Negative n times t. So if you multiply that and that together, you get back to the 30 that they had earlier.
Right.
2.5 times that, sorry. Right, now all I need to do here is calculations, but I don't trust my ability to do these. So I'm going to do number 1. Oops, too many zeros. Times number 2. Probably overkill here, 0.025 divided by 12. It's always a good idea to be generous about how many zeros you write down, or anything, how many digits you write down. This bottom one's going to be the real ugly character, and I just noticed a mistake, but I've should have caught that earlier. These are all subtractions. So back to the question. 1, take away a bracket. 1 plus 0.025 divided by 12. Close the brackets. Raised to the power negative 30. And on the bottom, I have 0.06 0.0528 and lots of other stuff. So I can now go 12,950 times 0.00208, lots of threes, divided by 0.0605258, and I come up with $445.75. So let me check that out. And that is the correct answer.
Okay.
So that's the guy you want for monthly payments, right? This guy. If you're doing stories like how much money will I have at the end or whatever, you know, the P1, the principal, if you want, you know, that one, use the top formula.